Good afternoon, everyone. It's a great pleasure to be here today at the Singapore Economic Policy Forum 2024. My name is QinXu, and I will be talking about exciting intersection of generative AI and finance. As we all know, the financial industry is undergoing a period of rapid transformation. And today I'll explore how generative AI is playing a key role in shaping this future, revolutionizing traditional financial activities and driving innovation in new financial products and services. Let's start by looking at just how popular generative AI has become in such a short time. We can gauge its success by comparing it to some of the biggest tech companies and their products. Meta, for example, took 54 months to reach 100 million monthly active users. WhatsApp hit this milestone in 42 months, and Instagram is 13 months. Even TikTok, which became a culture phenomenon, took 9 months to get there. Now what about OpenAI? OpenAI's ChatGPT reached 100 million monthly active users in just 2 months. This is unprecedented. It clearly shows how generative AI has captured public's attention and is reshaping our interaction with technology at an astonishing speed. So what exactly is generative AI? I asked ChatGPT, the newest version of ChatGPT, and here is how it breaks down. First, generative AI refers to a category of AI algorithms that can generate new content. The content is not limited to text or natural language. Generative AI can also produce images, code, music, and even videos. Second, it's important to understand generative AI is different from traditional AI. Traditional AI models are usually designed to make predictions or classifications based on existing data. They help us identify patterns, but do not generate anything new. Generative AI, on the other hand, creates original content. Finally, generative AI is not limited to just ChatGPT or large language models. There are many other generative AI algorithms. While generative AI is not limited to large language models, they have certainly become the dominant trend in driving its development today. Let's take a look at the evolution of language models over time. We have seen 4 generations of language models emerge, moving from being specific task helpers to becoming general-purpose task solvers. In the early stage, language models were designed for narrow, specific tasks, like answering questions or translating languages. However, as they evolved, their capabilities expanded dramatically. Today, they can handle a wide variety of tasks, from writing coding to generating creative content. As the scale of these models grows, so does their intelligence in solving complex natural language tasks. We are not just seeing an increase in data processing power, we are also witnessing a leap in how these models understand and generate human-like language. This evolution makes a significant shift from single-task tools to multi-purpose AI systems, making them an essential part of many industries today. This figure illustrates the timeline of large language models from 2019 to 2023. As you can see, over the past few years, many companies have developed their own large language models, and some even have multiple models. For instance, Google has launched several versions of its language models, but it's not just Western tech giants driving this innovation. Chinese companies like Huawei, Baidu, Tencent, and Alibaba have also joined the race, developing their own powerful large language models. This timeline shows just how rapidly this field is evolving, with more companies entering the space and pushing the boundaries of what these models can do. Generative AI is already making a significant impact in the financial sector. And many of these applications are documented in academic research. So here are just some examples of how this technology is being applied in finance today. These are just a few examples. But the potential applications of large language models in finance are far from being fully realized. So how we can use large language models to solve financial problems? There are two main approaches. And the first is using general purpose large language models like ChatGPT or Cloud. These models are designed to be highly versatile with the ability to answer questions across a wide range of domains, including business, mathematics, computing, healthcare, and of course, finance. The great advantage of this approach is that you can start using this model directly without any additional development costs. They're accessible and ready to use for various financial tasks, whether it's summarizing financial reports, analyzing market sentiment, or even predicting stock movements. However, there are some trade-offs. Since these are general purpose models, their performance on domain-specific tasks, for example, complex financial analysis, may not always be stable or accurate. Another key concern is data privacy. When using external large language models like ChatGPT, there could be potential risks around sharing sensitive financial data, which must be considered carefully. On the other hand, we can use domain-specific large language models that are tailored specifically for financial tasks. If you are working in the financial industry, you may prefer models that are optimized to handle finance-related tasks more effectively than general-purpose models. These finance-specific large language models are designed to have better performance on tasks such as financial forecasting, auditing, or risk management as they are trained with this domain-specific data. However, many of these projects are still in development, which means there is often no easy-to-use interface like ChatGPT. Typically, to get best results, these models require fine-tuning or updating with your own financial data to improve accuracy and relevance. Well, this requires more effort and technical expertise. The payoff is a significant improvement in performance for specialized financial tasks. With localized domain-specific models, organizations have more control over how the models are updated and what data is used for retraining. They can implement strict guidelines for types of data that can be used for model improvement and ensure that updates comply with existing privacy protocols. This control is often lacking in general purpose large language models, where updates are applied globally and without input from the end users, potentially creating privacy risks. And this slide shows the timeline of some classical financial language models that have been developed over the years. What's interesting to note is that these financial large language models are often built upon existing open source general purpose large language models with fine-tuning for financial tasks. For instance, the Finbert series, which is widely used in finance, was developed based on Google's BERT model. However, these early models have a relatively smaller parameter size, around 0.11 billion parameters, which limits their capabilities compared to the larger models. Fast forward to 2023, and we see the development of Bloomberg's financial large language model, which was built on the large-scale Bloom model. It has a much larger capacity with 50 billion parameters, enabling it to handle more complex financial tasks. Additionally, models like VMA and EY's LM based on Meta's Llama and FinGPT built on Llama 2 all exceed 1 billion parameters. These larger models represent a significant leap forward in terms of their ability to tackle the intricate demands of financial analysis. So Bloomberg GPT has an impressive 15 billion parameters, placing it in the same category as models like ChatGPT in terms of size. However, the key difference between Bloomberg GPT and a general purpose model like ChatGPT lies in the dataset used for training. Bloomberg GPT was trained on a mix of data with approximately 50% of data coming from financial sources and the other 50% from general purpose sources. For the financial data, it leveraged a variety of sources including web data, financial news, feelings, press releases, and proprietary data from Bloomberg itself. For the general purpose data, it includes widely available sources like Wikipedia. This combination allows Bloomberg GPT to excel at both financial specific tasks and general language tasks, making it a versatile tool for financial professionals. However, it is important to note, unlike some other models, Bloomberg GPT is not available to the public. Its use is currently limited to internal applications within Bloomberg. While Bloomberg GPT may not be publicly available, the good news is there are many other financial large language models currently in development. One exciting example is the QinXu project, developed collaboratively by several universities. It includes a financial language model called FMA, an instruction dataset named FIT, and an evaluation benchmark known as FLYER. So FMA is developed using Meta's Llama model, which is open source, allowing for more accessible development. Another great example of a financial large model is FinGPT, which is fine-tuned using a general purpose large language model. While retraining Bloomberg GPT would require at least $3 million, fine-tuning FinGPT costs as little as $300 per session. This makes it an accessible option for many business and institutions. Moreover, FinGPT is open source, which adds significant value. Not only can anyone use FinGPT for their financial tasks, but businesses also have the ability to fine-tune it further, tailoring it to their specific needs. This open access nature provides a higher level of security and control over proprietary data and business operations, allowing organizations to create their own customized financial language models without the need for expensive retraining. And this slide introduces the FinGPT Forecaster demo, an interactive tool that allows us to predict stock movements. By using the FinGPT model, this forecaster leverages financial data to make predictions on stock trends, providing valuable insights for investors and financial analysis. So financial large language models present a wealth of opportunities for transforming the financial industry. First, the rapid development of large model is opening doors for highly specialized financial models. We are seeing the rise of domain-specific large language models that are tailored to address the unique challenges and complexities of the financial sector, making process more efficient and accurate. Next, large language models are driving innovation in financial products and services. Generative AI allows institutions to create new financial offerings, enhancing personalized customer interactions and provide better insights through predictive analytics. This innovation improves value proposition and gives firms a competitive edge. Finally, the adoption of open source large language models offers a tremendous opportunity. Open source models like FinGPT provide cost-effective and customer-manageable solutions for business. By leveraging these models, companies can reduce document costs, accelerate implementation, and adapt models specifically for their own use cases, ensuring greater security and efficiency. While financial large language models offer immense potential, they also come with several challenges and risks that must be addressed. First, data privacy concerns are a major issue. Financial data is often highly sensitive, and using large language model to process this information raises concerns about data security and compliance with privacy regulations. Ensuring that models protect confidential financial data is critical. Second, model accuracy and bias can pose risk. Large language models may not always produce accurate or reliable outputs, especially when dealing with complex financial tasks. Additionally, these models can inherit bias from the data they are trained on, leading to biased decisions or predictions, which could affect fairness in areas like lending or investing. The cost of development and maintenance is another challenge. Developing and fine-tuning large language models for financial application is resource intensive, not only in terms of financial investment, but also in expertise. Companies need a team of skilled professionals, particularly those with deep knowledge in the large language domain, to effectively train, optimize, and maintain these models. This includes data scientists, machine learning engineers, and financial domain experts working together. Without this specialized expertise, ensuring that models function correctly and remain up to date can be difficult and costly. Finally, there are ethical concerns. The use of large language model in finance could be misused for unethical purposes, such as manipulating markets or automating decisions that have serious financial consequences. Ensuring that models are used responsibly and ethically is paramount. Thank you.